Hello students, welcome. In this lecture, we are going to solve some of the problems that are based on long transmission lines. Coming to the first question, it is given that a 500 kilometer three-phase long transmission line having parameters Z and Y and the parameters are per kilometer. The line delivers 40 MVA at 0.9 power factor lag at 220 kilovolt. Find the sending end voltage and sending end current. Find the power factor, MVA and power angle. I think this is sending end power factor, sending end MVA and power angle. So let us start. First thing is sending end voltage. What is the equation of sending end voltage? Vs is equal to AVR plus BIR, right? So first we need to know VR and IR. What is VR? 220K by root 3. We should take the voltage per phase. And generally the reference will be taken as receiving end voltage. If receiving end voltage is the reference, the angle will be 0 degrees. Next, what is current? IR is equal to 40 MVA by root 3 into 220 kV. And since it is 0.9 power factor lagging, the angle will be minus cos inverse 0.9, right? Let us calculate this. So after calculating, for me it came out to be 104.972 at an angle minus 25.84 degree ampere. Next, after VR and IR, we need to calculate the parameter A and P. So this is a long transmission line, right? We can either use hyperbolic functions or our approximated parameters. Since the calculation become very difficult, if we use hyperbolic function, we will go with approximated parameters. So what will be A? A will be 1 plus YZ by 2. So first we need to calculate Y and Z. Next, what is the value of B? B will be Z into 1 plus YZ by 6, right? Where Y and Z are the total admittance and impedance. I mean admittance and impedance for the total length. These are not per unit length values. So let us calculate. Z is given as 0.105 plus J 0.3768 per kilometer. If we want the total Z, we should multiply this per unit length value of Z with the total length of the transmission line, that is 500 kilometer. So let us see. And the answer is coming out to be 52.5 plus J 188.4 ohm. Check once. Next, let us calculate the value of Y. What is Y? J 2.822 into 10 power minus 6 multiplied by whole length, that is 500 kilometer. And the answer is J 1.411 into 10 power minus 3 mho, right? Next, we have the values of Z and Y. Let us calculate A and B. So what is A? 1 plus 5z by 2. 1 plus 52.5 plus J 188.4 into J 1.411 into 10 power minus 3 by 2. And here the answer is 0.867 at an angle 2.44 degree. Next, now let us calculate sending end voltage. Vs is equal to AVR plus BIR. A is 0.867 at an angle 2.44 into VR. VR is 220k by root 3 at an angle 0 plus B into IR. Wait, we should calculate B also. So B is Z into 1 plus 5Z by 6, that is 52.5 plus J 188.4 into 1 plus J 1.411 into 10 power minus 3 into 52.5. I should have converted this into polar form. This is very lengthy. By 6. So what is the answer? And after calculation, the answer is coming out to be 186.928 at an angle 75.17 degree. And this is coming out to be 124.361 at an angle 9.05 degree. This is phase voltage. So I am multiplying with root 3 to convert into line voltage. And the answer is 215.4 at an angle 9.05 degree, right? And next we need to calculate the sending end current. So what is the formula? IS is equal to CVR plus DIR, right? So we need the parameter C. C is nothing but Y into 1 plus YZ by 6. So I am calculating C here at an angle 90 into 1 plus 1.411 into 10 power minus 3 at an angle 90 into 195.578 at an angle 74.42 by 6. And the answer is coming out to be 1.3486 into 10 power minus 3 at an angle 90.74. This is C. Let me substitute the same thing here. So IS will be equal to C 1.3486 into 10 power minus 3 at an angle 90.74 into VR 220k by root 3 at an angle 0 plus D into IR. You know that A is equal to D. So D will be 0.867 at an angle 2.44 into IR. What is IR? 104.972 at an angle minus 25.84 degrees. Now throw this equation into calc. After calculating, the answer is coming out to be IS is equal to 157.71 at an angle 58.964 degree. Check this once. And these are our end results. So this question is completed. What is the next question? Calculate the sending end power factor. Power factor is nothing but cos of angle between voltage and current. So if you see here, let this be 0 degree. IS is at an angle 58 degree, let us say, and Vs is at an angle 9.05 degree. So here you can completely see that IS is leading Vs. So what is our power factor? Power factor is equal to cos of 58 minus 9.05 leading. Next, calculate the sending side MVA. So what is MVA? Root 3 Vs into IS, right? MVA is equal to root 3 Vs IS, that is root 3. What is Vs? 215.4 into what is IS? 157.71. Next, calculate the power angle. Power angle is nothing but the difference between the sending end angle and receiving end angle. If this is delta 1 and if this is delta 2, power angle will be delta 1 minus delta 2, right? So in this case, delta 1 is 9.05 degree and delta 2 is 0 degree. So our power angle will be 9.05 degree. If we keep the calculations aside, this is a simple problem. We just need to calculate ABCD parameters, and VR and IR are given in the question. We need to calculate Vs and Is, and from this the remaining parameters, right? Let me write the final answers. They are 0.644 lead, and this is kilovolt. The answer will be 58.839 MVA. Check this once. Coming to the next question, it is given that the parameters of long transmission line are given below. R and G are 0. So you can tell that this is a case of lossless transmission line. And the inductance and capacitance are given. Find characteristic impedance and propagation constant. For a lossless transmission line, characteristic impedance will be root over L by C. So this will be root over 1.2 into 10 power minus 3 by 3 into 10 power minus 6. Next, what is propagation constant? Gamma will be J beta, which is J omega root over L into C. Take frequency as 50 Hz. So this will be J 2 pi f into under root L 1.2 into 10 power minus 3 into C 3 into 10 power minus 6. You can calculate the answer. Next, in this question, he is asking us to calculate sending end voltage, sending end current, and sending end power factor. If the load is 200 ohm and in the second case the load is 400 ohm and the data given is characteristic impedance is equal to 400 ohm and beta is equal to 1.047 into 10 power minus 3 radian per kilometer. If you observe in this question, there is no data about R and G or propagation constant gamma, which is obviously equal to J beta, but he directly mentioned beta. So we should consider this line as lossless transmission line, right? Next, let us take the first case where load impedance is equal to 200 ohm. So to calculate the sending end parameters, what is the procedure? Yes, you know, right? Vs is equal to AVR plus BIR. And what are the ABCD parameters for a lossless transmission line? Cos beta L, JZC sin beta L, J sin beta L by ZC, and cos beta L. So Vs will be equal to VR cos beta L plus J into IR ZC sin beta L. And what is beta L? Beta L is equal to 1.047 into 10 power minus 3 into what is the total length? 100 kilometer. 100. So this will be 0.1047. Next, what is VR? VR is 100 at an angle 0. 100 at an angle 0 into cos beta L. What is beta L? 0.1047. Wait, this is in radians. You should convert into degrees. So multiply by 180 by pi, and this will be 6 degree. Cos 6 plus J. What is IR into ZC? In the first case, IR will be VR by 200, that is 100 at an angle 0 by 200. So this will be 0.5 at an angle 0, and IR into ZC will be 0.5 at an angle 0 into what is ZC? 400. So this will be 200, right? J 200 sin 6. Which is equal to 101.62 at an angle 11.87 degree. Similarly, you can calculate IS in the same fashion, which is CVR plus DIR, and this will be IR cos beta L plus J VR by ZC sin beta L. You know the value of beta L, you know the value of IR, and you know the value of ZC, you know the value of VR. This is the first case. In the second case, there is no need of any calculation. Why? Because here our load impedance is equal to characteristic impedance. This is the case of infinite line. And what are the results here? Vs will be VR at an angle beta L. Is will be IR at an angle beta L. You can write directly. What is beta L? 6 degree. And VR is 100. You should take only magnitude. And what is IS? IR at an angle beta L. Beta L is 6 degree. What is IR? IR is nothing but VR by ZL. That is, what is VR? 100 at an angle 0 by what is ZL? 400. So this will be your IR. If you substitute it here, you will get the equation for IS. Is this okay? So these are the kind of problems that can be asked in GATE examination based on this topic. They are pretty simple and of basic level. You just need practice. And GATE exam is all about solving numericals. So practice a hell number of problems. Then only you can get good score in the examination. And this is for now. See you in the next lecture. Bye. Take care.